Last unit, we did a ton of work. We did a ton of work on sine and cosine. A lot of work. We went SOHCAHTOA on the right triangle, and then we did where it was on the unit circle. This unit, you're going to graph them now on an XY axis. You're going to graph them. First thing I want to point out to you guys is look at the graph now. When I ask you guys to graph sine and cosine, take a look at the graph. Notice anything about the x-axis? Doesn't go by ones anymore, does it, like you're used to? It's in radians now. When we graph sine and cosine, expect your x-axis to be in radians. So, which means, everyone go to your calculator. Now, for the first time ever, you're going to be in need in what mode? Radian mode. So make sure you guys go to mode. Make sure radian mode is highlighted. Guys, that is the only time I'm going to ask you to be in radian mode. All right, that is the only time I'm going to ask you to be in radian mode. Okay, is when we are graphing. All right, so let's first take a look at what the sine curve should look like. So here's what you guys are going to do. You're going to type in, we're going to do the sine curve first, the sine curve. You guys are going to type in the radians, and you're going to let me know what the y values are. So the first thing you're going to find is, what is the sine of 0? So everyone go to their calc right now. Sine of 0 is going to be 0. So put a 0 in there. And we're going to keep going all the way down, but don't put in the degrees. Remember, put in the radians, because that's what we're working with. So next one, sine of pi over 6. Gives you what? 0.5, or I'm just going to write in the fraction, 1/2, right? 1/2. Okay, keep going. I'll do a couple with you, then you fill in the rest on your own. Pi over 3, we'll round this one because it comes out to be a decimal, right? We'll go about 0.87 for that one. 0.8, because you guys have 0.866. We'll do 0.87. Keep going. Sine of pi over 2. 1, yep. And then now you're going to start seeing a little pattern action happen here. You're going to start seeing a little pattern for the sine curve. 2 pi over 3, you're back at what? Yeah, 0.87. Then how about 5 pi over 6? You're back at 1/2, 0.5. And then at pi, we're back where we started, right? At 0, yep. All right, let's keep going. There's half of the graph right there. What about the other half? So 7 pi over 6. Shouldn't be 1. Should be negative 1/2. Okay, now we're dipping into the negatives. Which makes sense because now you're entering quad 3. And you guys know in sine in quadrant 3 is negative from last unit. So it should make sense. What's next? Negative 0.87. And then we go all the way down to negative 1 at 3 pi over 2. Keep going. We start repeating again, huh? Negative 0.87. We're heading back up, right? Negative 1/2. And then where does it end? Same place it started, right? At 2 pi, what's your value? Okay, everyone at home getting these values too, because now we're going to graph them. Okay, what does this look like on my graph right now? All right, first point we needed was 0. What's the sine value at 0? 0. So it's 0, 0 right here. Okay, you guys can know each marking here. Each marking is pi over 6, pi over 3, all right? It goes in order. So at pi over 6 it was. So take a look. Pi over 6, I graph 1/2. Pi over 3. Okay, 1, not 1. Pi over 3 wasn't 1. 0.87. So do your best. Do your best. You know, somewhere above 0.5, a little close to 1. Do your best here. 0.87, where that is. And now the next one is going to be right at 1. And then we start repeating itself, right? So make sure your points are on line now. Make sure they're on the same level. 0.87, 0.5, and then at pi, we're back at 0. Okay, let's go down now. Go into the negative. Let's go into the negatives now. Next one, negative 1/2. Negative 0.87. So just again, estimate again. Don't make it at -1, but make it pretty close. And then we're at -1. And then we start repeating, right? We're going to start repeating. And we end at 0. Okay, before we connect them now, this is a sine curve. A curve. Not a mountains, not a mountain range, not peaks and valleys, not a heart monitor at the hospital. It is a smooth curve. Okay, it is a smooth curve. There, you are looking at one full sine curve right there. That's what one sine curve looks like. Now, if we kept this going, listen here, if we kept this going past 2 pi, here's what would happen. It starts repeating again. Don't do this on your paper. Just take a look at mine. If I said, hey guys, let's go past 2 pi, that's what I would get again. And then would repeat again and repeat again. Okay, it's repetitive. After I do one curve that looks like this, boom, I start repeating again. Okay, any issues with what the sine curve looks like? Okay, I want you to write a couple things at the bottom because, guys, that's the last time I want you to do a chart to graph any sine curve. Last time I want you to do a chart. Here's what you're going to remember. Where did this graph start? At 0. We're going to call that the midline. Here's why. Hey, here's why I'm going to call it the midline. You see it's got a top value, a bottom value, and see the middle line in between? All right, so we're going to say it starts at the midline. Which was for us, I'm just going to put in parentheses, 0. Starts at the midline, 0. Okay, tell me where it went from there. Start following the curve now. Started at the midline, went up to where? Okay, anybody give me a nice mathematical vocabulary term for that highest point on the graph? Close.
Vortex.
No, the highest point.
The vertex?
Apex.
Highest point. Okay, I got apex. We don't usually use apex in that, but you are correct on vocabulary. Starts with an M.
Midpoint.
Highest point.
Max.
Maximum. Yes, maximum. That's its max, the maximum. So number 2 starts at the midline, goes to its max. Goes to the max, which was +1 for us. Okay, keep going. Keep following the curve. Where's it go from after the max? Back to where? Back to the midline. I don't want to say 0 because it may be different every curve. All right, so back to the midline. Which was 0. All right, keep talking to me now. It went back to the midline. Then where's the curve go to? Down to the minimum. Good. Goes down to the min, which was -1. And then where does it finish? It went down to the min, then finishes where? At the midline. Finish at the midline. Good. If you guys can just remember those 5 key points, you'll be fine. Guaranteed. No table or chart needed. Finish at the midline. And watch how easy this is going to become just knowing this right here. With the sine curve, where it starts, where it goes. Anything you want to ask about the sine curve before we do another one? So this was just, again, this curve right here was just, and it's already written, so This was just plain sine x. That's it. That's what that curve is, sine x. Now you go to the next one I'm going to ask you to graph. What's the difference between this one I'm going to have you graph and the last one? Simple difference. What's the simple difference between this one and the last one? Just look at the two equations.
4 sine x instead.
Now there's a 4 in front, isn't there, Mason? That's it. Everyone see the difference? Now there's a 4 in front. So the number in front, 4. Remember our last one? The min and the max went up to 1 down to -1. By putting a number in front, now it's going to go up to what? 4 and down to? That's it. That's all that number does. That's all that number does is tells us how high up and how far down it's going to go. That number out in front. Everyone at home, all right? So watch how quickly we're going to graph this now. Watch how quickly. Where's the sine curve start? Look back at your directions if you need to. Where's the sine curve start?
Midpoint.
Not the midpoint, no. Midline, at the midline. For us, the midline is always going to be 0 for now. After break, that'll change. But for now, it'll always start at the midline, which will be 0. Then it goes to where? Midline goes up to the max. What's our max in this case? Not 1 anymore, but 4. It's the number out in front. Yeah. So at pi over 2, I'm going to go up to 4 because this happens every 90 degrees. All right, where's it go now? Sine starts at the midline, goes to its max, then goes where? Back to the midline, which is what for us? 0 for now. Keep talking to me. Where else does it go now? Minimum. What's our minimum? -4. That number's powerful. Tells me what the max and the min is. Done. Then where does it end? Back at the midline. No table needed anymore. I just have to know the direction it goes. Smooth curve. Smooth curve when you graph it in. Everyone see how that worked? No, you do not need to memorize a chart or a table. The only thing you need is where it goes, where it starts and where it ends. All right? Questions there before we answer a few questions about this curve? Okay, can you go to part A, which is right above the graph? Part A. Can you guys tell me the x values where let's do this first. The x values where I had a maximum. So I had a max at x equals, look on your graph. The max, don't tell me what the max is. Where on the x-axis did you have it? Ready? Ooh, there we go. I have no idea. And I know I'm missing a couple anyway, so I'll fix it in a second. Why don't you settle down? Go ahead, Eliana. Where did I have max? Good, pi over 2. I had a max. Good, at pi over 2. Where did I have a minimum? I had a minimum at x equals. Some of you guys are just looking out because I don't have time to go over and change it right now. Dan, where did I have a minimum? At where? X equals?
X equals pi times 3 over 2.
3 pi over 2.
Pi over 2.
Yep. And then it says, where are my middle values? So middle values at? You're going to have to give me a couple answers here, aren't you? Where are your middle values? X equals what? You're going to have to give me a couple here. Here you go, Hunter. Give me a couple values. Where did I have the middle values at? X equals? Pi, yep. Couple more.
2 pi.
2 pi, one more.
0.
There you go. Good job. And that's what's going to happen every time with the sine curve until I change things up on you guys. All right, couple new vocabulary terms. What's the period of pi over 2? A period of 4 sine x. Okay, I'm not going to go into too much of what this is because we have a whole day dedicated to it coming up after break. Period, ready? How long it takes on the x-axis to make this curve. How long on the x-axis it takes to make this curve. I started at 0 and I ended up at what? So it takes a distance of 2 pi. That's going to be the case every time you're going to be asked period for now anyway. All right, it's going to take from 0 to 2 pi to make a full curve. Range, you guys know that now. Range, y values. Tell me something about your y values. From what to what? 4 to negative 4. I don't know. Here's how I'm going to have you write it, though. You guys remember using maybe parentheses and brackets last year? I don't want to write that old notation. Don't worry about that. I'm going to make it a lot easier. Trust me, a lot easier. I hate that too. Parentheses means it doesn't include the numbers. Bracket means it does. Is negative 4 part of this graph? Yeah, so I'm going to put a bracket and put negative 4. Is positive 4 part of this graph? Yeah, so I'm going to put brackets at both. From negative 4 to 4 with brackets.
What do you put if it's not included? Like
Parentheses, which we'll do here in a second coming up. All right? We'll do that in a second. What's the difference between the max and the min values? You guys can count on the graph if you want. The max and the min, how many units in between them? From negative 4 to positive 4, how many units? Back to you, Dan, back to you. What's the distance from the max to the min values?
Would be 8.
8, yep, 8, you got it. 8, negative 4 to 4, right, guys? 8. What quadrant, little review from last unit. What quadrant is sine positive in? What quadrant? 2n. There's another one. 2n. 1, yep. And then I got to show you this. I feel like I'm letting you down if I don't show you this. Why I asked that question. Quadrants 1 and 2 go from 0 to 180, right? 0 to 180. What do you notice about the graph from 0 to 180? It's above the y-axis, which means it's positive. It makes sense. And look at from 3 and 4, it's, yeah, okay, the graph is proving that too. I had to show you that because I love that. Not that you do. A couple more. All right, here you go. What interval is it increasing? Meaning where, everyone, take your pencil eraser, whatever. Where is it increasing on the graph? Okay, from what to what on the x-axis? Caroline, can you give me one? Go ahead, between what?
0 and pi over 2.
Between, everyone agrees? Between 0 and pi over 2, it's going up. Okay, so how do I write that? Ready? 0 pi over 2, but I don't want brackets here. Because at 0, it's just kind of there. It's not going up at 0, and it's not going up at pi over 2. So now is where I use parentheses, because it's not increasing at those two. It just starts and stops there. And then you know what? Cross off G. I don't care about this at all. That's not important to me. And it's not going to be important to you. Yep, go ahead, Caroline, go.
I thought the parentheses was if the point wasn't included.
No, correct. Yeah, it's not included. But it's increasing. Ready? So go, Caroline, if I go back right now at 0, that point's just there. It's not increasing. But as I go from 0 to 2 pi, all these points are going up and up and up until I get to pi over 2. What's that?
So any of those points on that line that's going up would be included?
Correct, yes. But not 0 and pi over 2 because it starts and stops there. It's not increasing there. Okay? And I'm glad Caroline asked that question because I totally blew this one. There's another spot. No one's going to call me out on that. There's more where it's increasing. Where else is it increasing? 3 pi over 2 to what? 2 comma 2 pi. And again, always parentheses because it's not increasing at those two spots. All right, you guys at home, questions, because I'm going to do a little change of plans as far as your notes go. Because we're in the sine mode right now. Can you guys go to number 5 for me? Go to number 5, last problem. Because we're in the sine mode right now. I just want to stay with the sine mode. All right, can you guys graph -2 sine x? All right, hey, we got a 2 in there. What's the 2 telling us? Max and min are going to be 2 and -2. Ooh, we got something a little extra in there, though, don't we, today? What's something new in that equation? The 2 doesn't bother us.
Go down.
The negative bothers me. The negative. So if I see a negative, ready? All I'm going to do is flip the graph over the x-axis. And I'll show you how to do that now. Anytime I see a negative out in front, we flip graph over x-axis. Here's exactly what I mean. You guys ready to graph? Okay, where's sine start? Oh, don't say it. I'm trying to break that out. Don't say 0. Midline, because sometimes after break, it's not going to start at 0. The midline will be somewhere else. Okay? But yes, it's at right here. That's where the midline is. Okay, ready? Settle. Everyone focus in. Then it usually goes to the what? Max. But I told you we're doing what? With the negative sign. So the max turns into the minimum. Flip it. So now it's going to go down to, yeah, -2. See where we're flipping it now. Where's it going to go to next? Back to the midline at 0. Usually it would go to the minimum here, but we're flipping things. So now it's going to go to the max, which is 2. And where's every sine curve end? Midline. There you go. And everyone take a look. This is the sine curve flipped over. That's embarrassing. You always know you're doing the curve right if it looks better than mine, because look at that. It's like, I'm done. You guys feeling good about the sine curve? I can throw a number out in front, and I can put a negative number out in front now, too. We feel comfortable. Guys at home feel comfortable? Because I got to switch it now on you and do cosine. All right, we're doing any issues at home, doing sine. All right, you ready for cosine now? Because cosine's a different beast. Okay, cosine's a different beast. Just for time's sake, because I don't want to run out of time today, I'm only going to do the key values. All right, so can you guys help me do 0, pi over 2, pi, 3 pi over 2, and 2 pi on your calculator for me? Now you're doing cosine, everyone. Cosine. Okay, do cosine now. So cosine of 0, what are you getting? Not 0 anymore. I got 1. Yep, cosine at 1 now. Doesn't start at 0.
Pi over 2.
Pi over 2 is what?
0.
0, yep. How about pi? Should be 0. Pi, right? Pi. -1, everyone. 3 pi over 2 back at 0. And then where's the cosine curve end here? At 1. 2 pi. So hopefully cosine 2 pi, everybody. 1. All right, let's graph them. And just remember here, you got to go halfway in between pi to get pi over 2. So 1, 2, 3. Just make sure we're graphing them at the right spots. So pi over 2. Halfway between pi and 2 pi is 3 pi over 2. All right, let's see what cosine looks like. So at 0, what's the value of cosine at 0?
1.
Okay, hey, make sure we're starting it at 1 now. And then it goes to where at pi over 2? 0. At pi? -1. Then back to 0, and then we finish it at 1. So looks a little different, doesn't it?
It's a problem.
All right. Looks a little different. I guess you could say that. That's a big word right there, parabola. Well, there is your cosine curve. And again, if I asked you to graph it past 2 pi, what would happen? It would repeat again. I'd get another one of these bad boys that looks like this, right? If I did it past. Okay, right below it. Give me directions. Directions. Where does it start? Don't tell me 1. No, it doesn't start at the midline either. That's sine. It does not start at the midline. Starts at 1, which is the, what do we call it? It's the highest point. Starts at the max now. Cosine starts at the max. Sine starts at the midline. All right, keep going. Where does it go after the max? Now it goes to the midline. So down to midline, which was 0 for now. All right, keep telling me. Max, midline to where? Down to the minimum, which is -1. Back to midline. And then where are we finishing? Finish at max, yep. So please know the difference between sine and cosine here. Very, very different. Finish at max. Okay? I couldn't even tell you. It's probably been 12, maybe 13 or more years I've been teaching this course, and so this might be an old reference. But kids always used to tell me the cosine curve looks like Arthur. Anybody remember the cartoon character? Arthur, yes, no? Books? No? They tell me that cosine curve looks like him a little bit. He was an anteater. Anybody remember that or no? Or is this reference way too? Anybody at home? Arthur the anteater? Arthur the anteater, anybody?
With the bang. There's something
Okay, great talk. Thanks for chiming in, you guys at home. We're going to be enthusiastic about it. Okay, so everyone all right with the cosine curve? Okay, now let's change things up. I don't want you to graph it. Not yet, anyway. Not yet. Now let's 1/2 cosine x. So in your mind, what are you thinking? What's that 1/2 doing to the curve?
Oh.
It's just going up to what? 1/2 and down to
So it's
-1/2, right? So it's a little bit more smushed. We'll graph it in a second. I just want to expose you to some vocabulary. We'll get more into it later, but amplitude. Amplitude. That's how high the graph is. Okay, and here's how we find it. Ready? It's a formula. We're going to, again, this will be the only time you use it today, but we'll use it more and more after break and we get deeper into the unit. Amplitude is 1/2 the max value minus the minimum value. That's how you find the height of any curve. You do the max minus the min divided by 2. All right, can you guys help me find that value? How high this curve is? What's the max value on this curve? I don't need to graph it. I can just take a look at the equation. 1/2 is the max. Minus, what's the minimum? Minus -1/2. Minus min,
okay.
right? Max 1/2, min minus a -1/2, and then subtract the 2. You good?
Yeah.
So yes, what's it become inside? Plus 1/2, right? So it's, what do you get inside the parentheses? 1, yep, 1/2 of 1, 1/2, yes. So it ends up being, yes, the number out in front. That may not be always the case, so I don't want to tell you that. Period. How long would it take to make one curve? Well, they're all going to take the same amount, which is what? 2 pi, yep. Always 2 pi for now. So enjoy it. Enjoy it. All right, what was the max again? 1/2?
I keep thinking of the other graph.
Yeah, that's fine. That's fine. And then what was the minimum? -1/2. And all because of the power of that number out in front. How do you write the range? We just went over the min and the max. How do I write the range of this curve now? Brackets. You brackets. Because it includes what? What's the range? -1. Make sure you always write the smaller one first. -1/2, +1/2. You ready to graph it? We're almost done here. Ton of time left too. Awesome. Anybody at home, issues? Okay, help me graph it. Here's where you got to be disciplined. This is cosine. Cosine. Where's the cosine curve start? Not at the midline. Maximum. What was our max for this curve? Okay, 1/2. So this one's going to be a little squeezed one. Where does it go after the max? Midline, which for now always is at 0. Midline, always at 0. Max, midline, we're not where? Minimum, what's the minimum for this curve? -1/2. To where? And then where's it finish? Cosine always finishes at the max unless it's flipped, but this one's not. Yep, so we got a tiny little sucker here. Definitely compressed a little bit. There we go. And then finally, where is this graph decreasing? From what x value to what x value is this graph decreasing? Find out where it's going down for me. On the x-axis, from what to what? Where is it decreasing? Colin, you got it? Where's this graph decreasing? From what x value to what x value?
From pi/2 to pi.
Okay, even more, even more. I agree, Colin. It's decreasing. You got more though.
And from 1/2 to pi/2.
Okay, from 0 though. Don't use 1/2. That's the y value. You want to use the. So you're telling me basically from here to here, right?
Yeah.
So on the x-axis, what's that from? From what to what on the x-axis?
0 to pi.
There you go. And we do it with parentheses, everyone. Brackets is for the range. When it's increasing and decreasing, we do the parentheses. Yes?
How come you don't put the bracket on the pi side?
Because Elliot, that's where it ends, right here.
Okay.
Like, is it increasing there or decreasing? No, it just ends there. So that's why I don't put. Good question. That's why I don't put a bracket around it. Okay. All practice tomorrow, as you guys know. Okay, all practice tomorrow. All right, it'll be worth a certain amount of points. You guys know the deal. If you're home, you'll take a picture, put it on Google Classroom. If you guys are here in class, you'll show me. All right, that's all I got for you. Thanks. You guys at home, do your part. Be smart. Because if I got to go in lockdown for 14 days, it's not going to be pretty.
My friend, she's a junior, she had to quarantine for the second time because of the kidney loss.
It's not even funny anymore.
Yeah.
Like, I'm not saying you were laughing, Kelly, but it's
Oh,
not
yeah.
even like.
She's like,
Went to school for one day.
And until you're in that position, like, people don't understand until you're actually in that position.
yeah.
Like, it's legit locked. Like, you're not going outside.
I mean,
You can go in your yard, but like going for a run, a walk,
They're trying to
lockdown.
make kids not come out for Thanksgiving.
What's that?
Like they're trying to make kids stay in their room for Thanksgiving.
Stay in their room? Well, I don't know about that,
I
but
know.
at least your house, I
Like
can
they're trying to
understand.
enforce that.
I'm not having these.
I can at least see.
My
Stay in
doctor,
your house,
he
but
was like, yeah, we're treating it
it's-
as normal. Like, whole family. My doctor literally considered
14 straight days without like going nuts.
True.
I can tell you already, going nuts.
Patron of our own.
working on Thanksgiving.
She's like Catholic. Yeah, it's kind of bad. But she visited me in the hospital, and that's when she said that. She's like, yeah, we're just gonna have everyone like the same that we usually do.
Is that your pediatrician? It's my daughter's too.
Patron Navarro?
Yeah.
Don't tell her.
I won't. I don't care. It's just my daughter's doctor.
Okay.
She's great to my daughters. I don't care.
Yeah, she's great. She just has opinions sometimes.
Okay. That's not what I'm there for, you know.
Yeah.
Make
Well,
sure
I
my
know
daughters stay
that,
healthy.
so-
right?
Her son goes to CVA and she says they don't wear masks in class. She's
That's
like-
hard to believe.
And she's like, yeah, it's fine because they're all 6 feet apart. I'm like, what if they sneeze? She's like, it's fine. Like, Queen, you're my doctor. Like, please. It's been I used to have Luthra. She's Indian. I love her. But she was always like, you're fat. You get on bike. But I loved her.
Why?
You have to ride on bike. I don't know. She's like, I really love
Mm. I haven't seen my TV fish in
Yeah.
a while.
I totally forgot over
Okay,
quarantine
we,
because I usually get
We escaped.
my
Big time.
like physical in March, and then like March didn't really happen, so I never went.
Thank
And then
God
I went
for-
in the summer, and it's like, oh yeah, I forgot.
The security cameras. Because if
I don't know.
they weren't out there
Last time I
filming,
went.
we
You
wouldn't
have
be
to
here
have
right
like
now.
certain vaccines.
Let me put it
and
that way.
stuff
Yeah.
To come to school.
And we
so
were
you
doing all the
probably
right
have
things.
that.
My mom's like had fifty bags. Like she, I could get some of them, but like I think the flu shot. Yeah.
The only thing with the flu shot is like you could get it because it's a live virus.
Yeah.
But what people don't get about the COVID vaccine is that it's like antibodies.
Yeah.
So when it goes into you, it's like,
And I didn't know we had a scientist in the house.
yeah, no, not really. Not earth science, that's for sure. Okay, I literally got the lowest grade on the earth science midterm in my class. And there were kids who just like this one. Anthony Fresco was my partner.
Oh.
Well, guess what? No.
Go to.
Yeah,
Go
he
to
carried
shop,
me
okay.
through those labs, honestly. He was half asleep, but it's okay. He's funny. One time he's like looking up the answers, and I'm like, Anthony, that's cheating. He's like, it's not cheating if you're skeeting.
Oh.
So, it was fine. And then he fell asleep.
Have a good one, guys.
Yo, Mr. Carlino. Have a great Thanksgiving. I'll see you next week.
Okay. Are you going to see Miss Burkhardt or not? Or do we have to actually physically get there? All right.
Bye!
Whatever.
Have a good day!
so fun.
Are there any more Unipack